Hi, very good afternoon to you. It's Jim from Maverickstar Observatory. I want to just explain something to you because not a lot of information is coming from the mainstream organisations, and I know a lot of people are going to say, well, that's because they don't want anyone to know really what is going on. You know what, I think sometimes, guys, we're giving them way too much credit, and you know, we expect their abilities to be a lot more in some scenarios than they actually are. You know, I don't think that a lot of these people that work for these departments do actually know everything about what's going on. The reason why we're concentrating on this, impression of what's happening over the northern hemisphere with regards to the strengths in microteslas over Canada and Russia is really self-explanatory. If you just look at the intensity rings, the white ones you'll see on the left hand side over Canada, it is shrinking off. In fact, if you look at the colour as time goes on, over 20 years that this has been modelled on, you'll see that the intensity over that region is dropping off quite dramatically. Yet over on the other side, where Russia is, you can see that intensity ring is increasing. Now, I'm going to tell you some things that is not being told to the general public. Clearly not being told. First things first, we've got two high intensities over the northern hemisphere of this planet. You can see them there. It's like we have two magnetic poles, only one dipole in the middle, and you can see that the dipole was originally in the 1900s or just before the 1900s over the highest intensity. What's been happening is the intensity over Russia has been increasing since the 1900s as it's been getting more stronger. That North Pole has been dragged over towards Russia. I'm going to show you on Google Earth where it exactly is going to head, because we know where it's heading. That's without a doubt. How it gets there is another thing that we're trying to work out. But right now we know that magnetic North Pole is moving for a specific reason. It's because the intensity which used to anchor it down over Canada is weakening, and you can see that for yourself. Over Russia, the intensity is increasing and it is stealing away the dipole from Canada. There's something else going on here. I want to just focus now on the southern hemisphere because I want to show you something. So I want to focus on the southern hemisphere now. Now, a lot of people are in the belief that the magnetic North Pole and South Pole are racing to meet each other somewhere over the equatorial region of our Earth, and it's not the case. There is no indication that they will do that at this point in time, because if you look at the west and east coast of Australia, you will see, despite the pole, the dipole of the southern hemisphere, or the south dipole, moving towards Australia, look at the intensity on the south coast of Australia. It's dropping off and it's being pushed back, even though the dipole is moving towards Australia. There's a reason for that, I think. And you know, I think more needs to be said about this, because if we now focus on that big dark blue region, off the top of my head, I think it's in the region of about 20 microteslas, as you can see. I haven't got that part included, but trust me, it's around about 20 microteslas or 20,000 nanoteslas, opposed to these higher intensities that are in red over Russia. It's in the region of 60,000 nanoteslas or 60 microteslas. Again, in Australia, we're around about 55,000 nanoteslas, and again down there in the South Peninsula by Australia, somewhere in between Antarctica and Australia, again around about 55,000 nanoteslas or 55 microteslas. If we focus on that dark blue region, for those that don't know, this is the South Atlantic anomaly, and if we just focus on that, we get another understanding of something else that's happening. And I don't think it's ever been described as a hole in the magnetosphere, but it certainly is that. and it's growing. And it is that it's because of this growing that the actual intensity over the South Peninsula of Australia is shrinking. It's being pushed. It's pushing the intensity back down in that region. This is bad for us because we could be witnessing right now taking place before our eyes. This only covers around about, well, I don't even think it covers 20 years of data, but what we could be witnessing is the depletion of our magnetosphere. And I'm going to show you in a minute on Google Earth. I don't think we are probably looking at, or at least at this point with the information we've got, I don't think we are looking at a reversal. We could be looking at something even worse. And the reason why that should be put on the table and analysed is because, you know, we went through regular reversals every 300, every 350,000 years regularly. And then all of a sudden, you know, for the last 780,000 years, we've not had a reversal. It's 500,000 years overdue. We could be looking at something even worse here, guys. Maybe planetary bodies, as will be probably understood in the future, do not have eternal magnetospheres. We've already seen Mars lose it, and it hasn't regained it. As a result of that, it doesn't have magnetic poles on the north and southern hemispheres of its planet. It also doesn't have an atmosphere, and it doesn't have water when we know it had it before. So maybe a key component of planetary mechanics, which will probably be better understood in the future, will be that the first thing you need is an active core that produces a magneto that sets up the magnetosphere. And if we are slowly seeing our magnetosphere, or the magneto, shut down, it's not going to be a good story at the end. Let's just put it that way. But I don't see what other people are talking about at the moment, where the poles are going to meet each other over the equatorial region of our planet. And the reason why I say that is because the South Atlantic anomaly, which is the lowest magnetic region on our planet, which is a hole in our magnetosphere, even satellites, when they go over this region, have to be precautious. You know, when the ISS travels over there, it has to be precautious over that region because it is in a weak field of protection, and therefore exposed to harmful cosmic radiation. This is one of the reasons I've been banging on for the last year now why we need in Brazil one of our magnetometers so that we can monitor this, because I don't think we should be relying on the larger organisations like the European Space Agency and NASA. You know, we don't rely on them for the pinpointing of the magnetic North Pole, which we'll be doing in a few days. And, you know, we shouldn't be relying on them to give us information about these regions that we've got around our planet that are, you know, going through dramatic changes. We've got a magnetometer in Perth, Australia. We've got magnetometers in Arizona and America, so that we can watch that retreating magnetic intensity as it leaves Arizona. We'll be able to detect it. You know, again, we've got one in Canada, which is right where the epicenter of that weakening intensity is. We could, you know, benefit from having one in Russia, and we could definitely benefit from having one in now Brazil. And as you can see, that South Atlantic anomaly is not only stretching over the south coast of Africa, but we could definitely do with one there to see and monitor how that is progressing over that region. And, you know, if we can get a few more magnetometers out into the field, you know, we can also do some mean averages of the magnetosphere strength. The way we done it the last time is we calculated all the regions of intensity, and, you know, we divided that by the number of regions with high intensity, and it gives us a figure of 50 microteslas. I believe that that number could be dropping off as we see the South Atlantic anomaly weakening even further and spreading further over Africa, maybe, you know, going towards Australia itself. And, you know, I'm interested to see what will happen with the dipoles. I'll just put this out there. I don't think the dipoles are that important. I think what's important is the intensities that are changing in strength around our world, because that intensity is what gives us our protection from, you know, cosmic rays, you know, increased risks of cardiac arrhythmia failure. You know, those are the things that we should be focusing on. I'm just putting that out there. So we know where the magnetic dipole is heading, and, you know, I said one of the questions that we had to try and effort in answering is, how fast is it going to get there? Well, if I just zoom out a little bit on this Google Earth map, we can see where the poles are roughly at the moment. The dipole is in that region. That's what we track. Like I said, I don't think dipoles are that important. We should be focusing more on intensities in these regions, but we'll just make a measurement, because I suppose it does give us a good indication of how things are progressing with regards to the actual dipole increasing in speed in shorter time spaces, or should I say increasing distance in shorter time spaces. So I'll just make a measurement roughly of how far we are off from where the epicenter is over Russia. I've done this earlier. It's showing 1,352, but when I measured it a little bit more accurately earlier, it was at 1,374 miles. And we know at its current rate the dipole is moving around about 5.1, 5.2 miles a month. That gives us, you know, if it doesn't accelerate when it gets to the 40-degree mark, and doesn't behave as I demonstrated it might do in that theoretical theory I put out there, and in the experiment that I showed you guys, if it doesn't accelerate from that point, we stand at the arrival of the North Magnetic Dipole reaching its location, where it's heading. We know why it's heading there now, because the intensity is increasing. It should be there in around about 269 months, which is 22 years from now. That's if we don't get to that 40-degree mark and something else happens. Because you can see for yourselves, guys, how close we are to that 40-degree mark. Especially if I just zoom in for us. And based on its current trajectory, you know, we'll be there in 8 months. We will be entering, if that theory is anything in it, and it is just a theory, if it has anything in it, you know, we will be there in 8 months at the current rate at which it's migrating. We will be at that point where, you know, the strong field lines are no longer able to hold on to that magnetic dipole, and it enters the weak field lines and it moves much faster. But there's something else I wanted to just share with you, because I think it's important to put things on the table. So I just wanted to, you know, put this down on the table, and you tell me what you think of this. You know, obviously we're not the only ones here with the knowledge of the migrating magnetic North Pole, and of course in the top left we're looking at temperature, on the bottom left we're looking at the intensity, and we can see that where the intensity plumes are the coldest regions on our planet, and where the lowest magnetic intensity is, where it's Mach 8, which is the South Atlantic anomaly, these are some of the warmer regions on our planet. I don't think that this is by any coincidence. I do believe there is evidence to support that where the most severe climates are on our planet are not just by coincidence to have magnetic fields in them as well. And I also say this about the rotational axis, because these are the 3 main anomalies on the north and southern hemispheres of our planet. Now, getting back to the fact that, we're not the only ones that know what's happening. If I'm right, and what I mean by if I'm right about this theory, that where that magnetic dipole ends up is where one of the coldest regions on our planet will be for a very long time. If that's right, then we know that there is more severe Arctic climate heading absolutely 100% to Russia. And I just want to put this out there. It could just be an idea, but do you think Russia know about it? And that's why they're making a move on land grab in the Ukraine. They've talked recently about Alaska belonging to Russia. Are they worried that when that pole arrives in central Russia, that it also brings more dramatic and severe Arctic climates with it? And will that slow down, Russia's ability to maintain itself and its continuity at that point? Just putting these ideas out there, guys. We know that Ukraine produces, I think it's around 30% of the world's wheat, produces a lot of sunflower oil. I know a lot comes from Russia as well, but this is a very serious threat that I think does carry weight. I think it is more than plausible. Look, you're looking at a temperature chart on the top left and a magnetic intensity chart on the bottom left. Where those arrows are the more warmer regions. Where the circles are the more colder regions on our planet. Is this Russia making its move? I'm just putting it out there. I mean, we've got a lot of other things to worry about in any case. I mean, if you ask me, if you want my opinion, the northern and southern hemispheres of this planet are on borrowed time in any case. We don't need to be studying the field of magnetics to know that. We just need to have a look at the Milankovitch cycle and the past interglacial and glacial cycles. We know the northern hemisphere is on borrowed time. Look, it wasn't 300, 400 years ago when, the entire continent of Canada was uninhabited. It's only because it got warmer during the last interglacial cycle that it became inhabitable for human beings to live there relatively, in reasonable climates. Before that, it was uninhabited, just like a lot of places on our planet. And you have to ask the question, why is that? Why is Australia originally only inhabited by native Aborigines? The only people that lived in Siberia and over in the northern hemispheres of Canada was Eskimos. People that couldn't live in large numbers because of natural selection. This is what I'm trying to tell people. This is really the stuff that the organisations should be telling people. This is where the money should be being invested right now, and it simply is not. You have no protection on your infrastructure. If you're living in a city, it's only a matter of time. Do you understand that? It's only a matter of time. You cannot sustain yourself in a city, and that's why when people ask me, where's the best place to be? The only place I could suggest, if you're not going to be freely moving around this world, because we are living in a world where it is fluid and the climate is shifting all the time, so you might find yourself in a nice place 1 minute and in 10 years the climate's changed again in that region. The only other way, the only other safe place I could suggest to anybody would be a coastal region, and then you have your dangers with that. But the only reason I suggest that is because it is still, even though it isn't as it used to be, there is still an abundant amount of food that can easily be catched along the coastal regions. This work is far from being finished, guys. We need to be doing a lot more, and the time is ticking. We need to do a hell of a lot more, because right now everybody's waiting and waiting for these organisations to tell them about what really they should be focusing on and what is going on in their world, when what people are really getting is a £10 million photograph that's been enhanced by an artist. I'm talking about the James Webb telescope. If it really is a truly a thermal image that has been taken over an exposure of 12.5 hours, then it certainly is not going to be in colour. You do understand that, don't you? £10 billion? I think we know where the £10 billion went. It didn't cost £10 frigging billion to build a telescope. I don't care what anyone says. It doesn't cost £10 billion to build a telescope and put it out in space, regardless. Guys, we need to be doing more. There's no one else helping us. We've got to look after ourselves here. You know, if you want me to, you know, invest the time getting more equipment out there into the field so we can monitor this ourselves, there's a link down there in the description. The only other thing to say is, you know, I hope that you start to realise that what we talk about on this channel is not pipe dreams. You know, these aren't fantasies. Your world is changing before your very eyes. And, you know, we need to take precautions. You know, the train is approaching us. We've got to step off the track. Guys, there is a lot worse things you can do with your money than support an observatory that is monitoring these things for you. A lot worse things. And we really need more than just one or two people that view out of the 3,000, 4,000, you know, viewers every day or every other day, or when we do a video. We need more than those people to come forward and support us. So there's a link down there in the description. It's as simple as that. You know, the only other thing for me to say is you take care of your loved ones. As always, bye for now.